Hello, my name is Michelle, and I want to do a I2C type project. And so I ended up creating first my printed circuit board so that I could install an I2C EEPROM on it. So I had a slave device that I could test with. Ultimately, my plan is to write an I2C master driver in my FPGA to write and read data to this EEPROM, the I2C EEPROM. And so I started off, this would be my first printed circuit board that I've ever done. And so I went into EasyEDA online. And as you can see, I designed this printed circuit board where basically it had a PMOD connector so that it could plug to my FPGA. I did some LEDs on here just so that I could do some status stuff if I wanted to. But predominantly for this, basically I'm just sending in my my SDA and my SCL, my clock and my data are coming into this board. All right. And then, of course, from this board, it is going to my EEPROM here, which is in this case was an AT24C256 EEPROM. And it was basically a 256 byte EEPROM device. Pretty much at this point in time, I set the address to 0, which in hindsight now I wish that I had maybe put a dip switch in here so I could select that. But basically, here's my clock and my data coming in, and then I have my my resistors for the bus that the I2C would talk on. And basically that's and also I probably would have put another jumper here for the right protect. So there's a very basic schematic here. And then of course I went out and created my printed circuit board. And you can see this was basically the layout that I went with. So here's my PMOD connector here. Here was my LEDs and the resistors just so that, they don't get too bright. My two resistors for my I2C bus, my ceramic capacitor for power control, and then basically my EEPROM chip. What I would have done different on this layout that I didn't do and I should have done is I probably would have labeled my pins here. So I would probably have made a little more room here and labeled my pins better. Also, now, I mean, right now I have all the layers hidden except for the top layer, but I want to go ahead and show you. Once I laid out my pins, I did go ahead and flow the top and bottom layers. This is a 2-layer PCB with a ground plane. So I'll go ahead and show you my layers so you can see. So now we'll be able to see the top layer here. And as you can see, these are the traces that I used just for the top layer, which is predominantly the power. And of course, it's floated. This is all ground plane floating. So we'll remove the top layer and look at the bottom layer. And most of my routing of my signals went across the bottom layer. And as you can tell, again, notice though the blue here, this is all ground plane going on. It's just blue. And so that way I tried to minimize noise and things like that. So that's what my printed circuit board looked like when I designed it and I sent it off to be printed. And this is what my printed circuit board looked like when it got here. There it is. And sure enough, just like it on the design, like I said, my mistakes, I forgot to label the pins. So I had to pay really close attention to the schematic on what pin went to what. And other than that, that's that. And then, like I said, I probably wish I had have put, what was the other thing on here? Anyway, can't remember again now. So Then I went ahead and put the components onto the board, which you can see right here now. Basically, these are all 4.7K resistors. This is my EEPROM. This is my ceramic capacitor. Here was my LEDs. And then after, like I said, looking at the schematic and putting it together, I got the pins laid out here on what was what. These are power and ground. And then I think this is clock and data, I believe. I'd have to go double check that one. It could be backwards. Anyway, right, this is an ESP32 microcontroller that I have plugged into two breadboards just so that I could, connect to the pins. And so I have my clock and my data plugged in here to communicate to it. And of course, I'm connected to my PC to be able to do communication to the device. So basically, at this point in time, until I had built the PCB up. It's now has the integrated circuit in it, but I needed to test to make sure this was correct. I did go ahead and immediately put some power to it and check the LEDs, and they all lit up like they should. However, like I said, I needed to verify that I could read and write to the EEPROM via I2C, because in the future I want to go ahead and connect this to my FPGA. But at this point in time, I just wanted to use a microcontroller that already, was using I2C. Makes it really easy. And so at that point in time, I went ahead and I went on the internet and I found some I2C tutorial stuff. This one here by Spark Fun, they actually, and here's the address, by the way, they actually had this really nice how to clear the memory. They had other things in it, but this is very high level code here, and it was higher level code than I wanted to play with. I wanted to go a little lower than this. And so all I use this for right now is to, this is basically 256K of RAM. So we were definitely, I just wanted to go clear the memory. And so I'm only using this code. Like I said, it's basically some very, very high level code to go out and clear the RAM with zeros and then reading each, like address 0, reading address 10, address 20, and telling me if what it did, okay? And so at this point in time, what I'm going to go ahead and do is I'm going to run this, and it should basically, it'll compile, it'll run, and then what it'll do is it'll display that, was clearing the memory, and then it'll display that what it read. And here it goes. So it's programming the board now, where we're at it. So we know it's communicating. So that's a good thing. And it says the memory was detected. The memory size in bytes, that's the size that it recognized. And so it cleared the memory, and of course it read at those three addresses and all are zeros. So it zeroed it out, just like I hoped for. Now, after some work and some, doing some work on how wire works, I went ahead and wrote kind of like a read-write EEPROM code. And I have a friend of mine named Neil. He kind of helped me out. So his name is credited in here for what we were doing. But we went ahead, we had discovered, obviously, from the EEPROM, from the spec, that this EEPROM was address 50. Because of this EEPROM, the best block size was 64 bytes. I think it's bytes. I should have commented that out. So then we went ahead and basically I wrote a clear EEPROM in wire, but I didn't like what it did. So I went ahead and didn't use it, or it was really slow actually. I'm going to fix that. Here basically I just said, okay, we're at address 0. I want to write my age. So that's my age. And then I have a message that I'm going to write later. However, you got to realize that this is going to be in binary, and so when we read by back binary 59 that is actually a semicolon, believe it or not, surprisingly. Oh well. So basically, what this is going to do is it's going to read a block of memory from address 0 to 300, and it's going to display what it sees, and it should be nothing. Then we're going to write the data, which is in this case 59. Then we're going to go out and read that data, and we should get a 59. Then we're going to go out and read a block again. In this case, there should be nothing there but a semicolon because that's what 59 represents. And then we write a block of data with our message, which in this case we modified because we did modify some code. We had a basic level of code, then we modified it. So I wanted to give credit that we modified it. Modified by Michelle Neal just for a little bit of fun. And then so we wrote that message, and then I went out and read the message. Down here is our code where you can see where we're writing a character. We're basically beginning our transmission, putting in our beginning address, ending address, and then writing the data, and then ending our transmission. On the reading character, you begin your transmission, you write out your beginning and ending address, you end your transmission, then we do a request from the device, and we read the data. And in this case, we're just outputting it. We're returning it up to the top and then outputting it. Writing data, in this case, here now we're going to write a block of data. This took a little bit of effort, I will tell you, to get going. But basically, we're bringing in a character array, and we have our length of the character array here. And then so while we have not sent it all over, we're going to keep writing. And then we're writing by block size. So we're making sure that we're only writing it in block sizes to make it less destructive on the EEPROM. So basically, we begin our transmission. We write our begin address, our ending address. We go ahead and we write out our each block size worth of data of our whatever we're doing. Then we end our transmission, and then we increment our block size, that like we said. And then if we've not written it all out, we go back out again and we do it again. We begin transmission. The address gets incremented by a block size, and so we just keep writing over and over and over again until we've actually completed writing the message. On the read block, basically we're just saying for basically our beginning address until we get to the end address, we're just going to basically receive a character at that address, and then we're going to output that character, and just we're printing it out. Like I said, the clear EEPROM, that one I didn't like. It's a little too slow. So basically, there's the code of what we did. And so now I'm going to run that. Let me double check I got my, yep, I do. Okay, good. So we'll run this code. And I'm going to open up my monitor screen. Like I said, we should get nothing as the initial value. Then we'll write a 59. We should get a 59 back. Then we're going to actually read, and we should just see a semicolon. We'll write the message, and then we'll read, and we should get the same message back. And there you go. So we were reading the block data. There was nothing there. We wrote 59. We read back. We got 59. I read a block again. There was what 59 represents in ASCII. We wrote a block of data again. So there was my statement. And then I read the block back. And so there you go. I just created my first printed circuit board. I soldered in the components. And then I went in with my multimeter and I tested everything out to make sure I didn't short anything and everything was good there. Did a little bit of a power check, made sure my LEDs were working. And then I used this ESP32 to verify that I could read and write on this printed circuit board that I created onto a I2C EEPROM. and therefore I've proven that this works. So there you go. I hope you enjoyed this. I will create another video when I'm done getting the FPGA to work. All right, thank you very much.